So we've got 20 small lamps and they're connected in series with a 9-volt supply, and hopefully you can remember the rules for the voltage and the current in series and parallel circuits. So the rule that we're interested in is the voltage in a series circuit. Okay, I'm going to see that the voltage is shared, so the 9 volts is going to get shared between the 20 lamps, and that means that each lamp is going to get 0.45 volts. There is one assumption that we've made, and that is that all of the lamps are identical. Okay, but I think that that's a reasonable assumption to make in this question. The equation linking power and current and voltage is P equals V times I for an easy mark, and we need to show that the current in the circuit is about 3 amps. So it's given us each lamp has got a power of 1.5 watts. So we substitute into the equation, or you can rearrange first. It doesn't really matter. We've just worked out that that's 0.45 volts. Okay, times by I. Okay, so that gets us 3.33 reoccurring amps. And just to finish off the question neatly, they've asked us to show that that's about 3 amps. So the way that we can do that is to write a squiggly equal sign to show that that's approximately equal to and 3 amps. Now if we're trying to calculate the total energy transferred, then we need the EVIT formula, E equals V times I times T. I've got to be a little bit careful here because we want the total energy transferred. So that means that we're going to need the 9 volts, okay, which is the full supply voltage. You can use the 3.3 amps that you've just calculated, or you can use the 3 amps that they gave you in the previous question. That's no problem. Okay, and then the next bit is we've got to work out the time. Now if it's on for 5 days and it's on for 7 hours per day, okay, then that's 35 hours. But of course the SI units for time aren't hours, they're seconds, and to turn it into seconds we've got to multiply by 60 seconds in a minute and 60 minutes in an hour. Okay, and if you bash that through on a calculator, you should find that that's 3,742,000. Okay, and again, we could argue about the number of significant figures that are given there. Okay, it might be more appropriate to round that off to 3,700,000. Okay, but again, that's you're not penalised for the amount of significant figures that you give in this question. And the last part of the question is to describe the energy changes that take place in the lamps. So what's the energy that's going into the lamp? It's electrical energy. Okay, notice that it's electrical. That AL is important. If it isn't there, you don't get the mark. And the electrical energy, the main energy transfer is that it's turning into light energy. Okay, and there'll also be some thermal energy, some heat energy wasted as well. Okay, but the 2 main marks are for electrical and for light.